December 16th, 1944, 5:30 a.m., the Ardennes Forest, Belgium. Colonel George Axelson gripped his field telephone as panicked reports crackled through the static. German panzers were smashing through American lines in what would become the Battle of the Bulge. The 38th Cavalry Squadron was getting slaughtered near Monschau, their desperateering across the frozen pleas for artillery support Eck battlefield. Axelson stared at the wooden crates stacked in his ammunition depot, each one marked with red warning labels and classified stamps. Inside those crates lay a weapon so revolutionary that Allied High Command had forbidden its use on European soil for over a year. The fear was simple. If the Germans captured even one intact example, they might reverse engineer the technology and turn it against Allied bombers filling European skies. But as German artillery began pounding American positions and SS troops advanced through the snow-covered trees, Colonel Axelson made a decision that would change warfare forever. He picked up his radio and transmitted 4 words that would unleash technological devastation upon German forces. Load the funny fuses. What happened next defied everything German military engineers believed possible about artillery warfare. Shells began exploding, not when they hit the ground or struck targets directly, but when they passed overhead, at precisely the right altitude to rain shrapnel down upon German soldiers. Foxholes offered no protection. Log-reinforced bunkers became death traps. Communication wires were severed instantly. Within minutes, the German offensive collapsed as soldiers emerged from the barrage in what American intelligence reports described as a dazed state. The Germans had encountered something that their most brilliant scientists had declared impossible to build. A device so technically challenging that German engineers had abandoned their own proximity fuse programs years earlier, convinced that no nation could overcome the fundamental physics problems involved. They were about to discover just how catastrophically wrong they had been. This is the story of how American ingenuity created a weapon that German arrogance refused to believe could exist, how 22 million miniaturized radar systems packed into artillery shells transformed near misses into devastating hits, and how the most significant intelligence failure of World War II occurred when German forces literally captured 20,000 examples of this revolutionary technology, but dismissed them as worthless because their own experts had proven such devices were scientifically impossible. The proximity fuse represents one of the greatest technological achievements of the Second World War, rivaling the atomic bomb in its strategic impact, while remaining almost completely unknown to the general public. German military engineers who encountered its effects in combat described it with a mixture of terror and disbelief. American commanders called it the funny fuse because of its uncanny ability to explode at exactly the right moment to maximize destruction. But the story begins years before Colonel Axelson's desperate gamble in the Ardennes, in the laboratories and research facilities where American scientists were attempting to solve what many considered an impossible engineering challenge. The technical requirements seemed to defy the laws of physics as understood in the early 1940s. Engineers needed to create a device that could fit inside a 5-inch artillery shell already packed with 7 pounds of high explosive. This miniaturized radar system had to survive being fired from a cannon, experiencing acceleration forces equal to 20,000 times the force of gravity. The shell would spin at nearly 30,000 revolutions per minute as it screamed through the air at 2,600 feet per second. The device had to operate flawlessly in temperatures ranging from 100 degrees above zero to 50 degrees below zero. It needed to detect aircraft traveling at 300 miles per hour and detonate at precisely the right distance to maximize shrapnel effectiveness. All of this had to be accomplished using 1940s electronics technology in an era when transistors and integrated circuits existed only in the imagination of theoretical physicists. Most importantly, the device had to be mass-produced by the millions at a cost low enough to be practical for battlefield use. Each proximity fuse required approximately 130 individual electronic components, all manufactured to tolerances measured in thousandths of an inch. The technical challenges were so daunting that when German scientists examined the same problems, they concluded the entire concept was a fantasy that would never work in practice. This German dismissal would prove to be one of the war's most costly miscalculations. The American development program began in 1940 under the direction of physicist Merle Tuve at Johns Hopkins Applied Physics Laboratory. Section T, as the program was designated, operated under secrecy rivaling the Manhattan Project. An estimated 3% of all physicists in the United States worked on proximity fuse development at the program's peak. Like the atomic bomb project, it required breakthroughs in multiple scientific disciplines simultaneously. Unlike the atomic bomb, it demanded solutions that could be mass-produced by American industry at unprecedented scales. The first major breakthrough came from an unexpected source. Engineers discovered that miniaturized hearing aid tubes, originally developed for civilian medical applications, could be modified to survive the extreme forces of artillery firing. Working with Western Electric Company and Raytheon Corporation, researchers created vacuum tubes smaller than a human thumb that could withstand forces that would instantly destroy conventional electronics. These tiny components became the heart of a complete radar system compressed into a space smaller than a pint milk bottle. The engineering challenges seemed insurmountable to outside observers. Creating a battery powerful enough to operate the radar system while surviving the shock of cannon firing required developing entirely new electrochemical processes. The antenna system had to be designed to function while spinning at tremendous velocity. The timing circuits needed to distinguish between ground clutter, friendly aircraft, and enemy targets in the split seconds available before impact. Safety mechanisms were essential to prevent premature detonation that could destroy the firing gun and its crew. German engineers examining these same technical requirements had reached logical conclusions about their impossibility. The acceleration forces alone seemed sufficient to destroy any electronic device. The spinning motion would create centrifugal forces that should tear apart delicate components. The harsh environmental conditions would cause batteries to fail and circuits to malfunction. The miniaturization requirements exceeded anything achieved in the 1940s electronics manufacturing. German proximity fuse programs were abandoned not through lack of effort, but through rational assessment of seemingly impossible technical obstacles. What German scientists failed to anticipate was the scale of American industrial commitment to solving these problems. By 1944, a large proportion of the American electronics industry had been converted to proximity fuse production. Procurement contracts increased from $60 million in 1942 to $450 million in 1945. Over 100 manufacturers across the United States contributed components and assembly capabilities. The program represented an unprecedented convergence of scientific research, engineering innovation, and industrial mass production. The first combat test occurred almost by accident on January 5, 1943, in the Solomon Islands. The cruiser USS Helena was conducting routine anti-aircraft practice when Japanese dive bombers attacked the task force. Helena's gunners fired 2 salvos of 5-inch shells equipped with the new proximity fuse at departing enemy aircraft. One of the Japanese Val dive bombers suddenly exploded in mid-air without being directly hit. The shell had passed close enough to the aircraft to trigger its radar sensor and detonate at optimal distance for maximum shrapnel effect. Though the engagement received no public attention, it marked a transformative moment in the history of aerial warfare. For the first time in military history, an enemy aircraft had been deliberately destroyed by a near miss. The success convinced American military leaders that they possessed a revolutionary weapon, but also reinforced their determination to keep it secret. Initial deployment was restricted to situations where captured fuse could not fall into enemy hands. Naval engagements over open ocean were considered safe because any unexploded shells would sink to the bottom. Land warfare remained forbidden because of the risk that German forces might recover intact examples and attempt reverse engineering. Obsession would create. This security one of the war's greatest ironies. German forces would eventually capture thousands of proximity fuses but never recognize what they had obtained. The technology that was systematically destroying their military effectiveness remained invisible to their intelligence services because their own experts had proven it could not exist. The devastating effectiveness of proximity fuses became apparent during the defense of London against V-1 flying bombs in the summer of 1944. The pilotless missiles approached at 400 miles per hour, making them extremely difficult targets for conventional anti-aircraft fire. British gunners using traditional contact fuse achieved hit rates of less than 5%. When proximity fuses were installed in British and American anti-aircraft ammunition, the destruction rate jumped to 79% of all incoming V-1 attacks. The buzz bombs that had terrorized London civilians were suddenly being destroyed with mechanical precision that seemed impossible to German observers. German military intelligence reports from this period reveal growing confusion about Allied anti-aircraft capabilities. Luftwaffe pilots reported that American and British gunners appeared to have developed supernatural accuracy. Near misses were somehow causing aircraft to explode as if directly hit. German engineers studying crashed aircraft found shrapnel damage patterns that made no sense according to conventional ballistics theory. The fragments seemed to come from shells that had detonated at impossible distances from their targets. What German analysts could not comprehend was that they were witnessing the results of a technological revolution that their own scientific establishment had declared impossible. American proximity fuses were turning artillery from a weapon of direct hits into a weapon of calculated near misses. Every shell that passed within lethal distance of its target became a devastating airburst that scattered shrapnel across a wide area. The mathematics of destruction had been fundamentally altered in America's favor. The transformation of artillery from a weapon requiring direct hits to one that killed through calculated proximity represented a paradigm shift that German military doctrine simply could not accommodate. Traditional artillery effectiveness had been measured by accuracy, the ability to place shells precisely on target. German gunners trained for years to achieve the precision necessary for direct hits. Their mathematical tables, firing solutions, and tactical manuals all assumed that destruction required physical contact between projectile and target. American proximity fuses obliterated these assumptions overnight. Suddenly, every shell that passed within a predetermined distance of enemy forces became a lethal weapon. The kill zone expanded from a few feet to dozens of yards. Artillery batteries could achieve devastating effectiveness without the pinpoint accuracy that had defined gunnery for centuries. German soldiers discovered that their traditional defensive tactics, developed through years of combat experience, offered new forms of warfare. The psychological impact proved as devastating as the physical destruction. German infantry had learned to survive conventional artillery through techniques passed down from the trenches of the First World War. When shells approached, soldiers dove into foxholes, pressed themselves against the earth, and waited for the explosions to subside. These time-tested survival methods had saved countless lives throughout the war. Against proximity fuses, these same techniques became death sentences. Obergefreiter Hans Müller, captured during the Battle of the Bulge, described the experience in his interrogation report. The shells exploded above us without warning. We heard no impact, no ricochet, just sudden detonation in the air. Our foxholes became traps. The shrapnel came down like metal rain. Men who had survived years of combat were cut down in seconds. We could not understand how American gunners had become so accurate that they could make shells explode at exactly the right height. German field commanders quickly recognized they faced a new type of warfare, but struggled to develop effective countermeasures. Traditional smoke screens offered no protection against airbursts. Dispersed formations reduced casualties but made coordinated attacks impossible. Underground bunkers provided some safety but severely limited mobility and tactical flexibility. Every defensive adaptation seemed to play into American tactical advantages. The communication disruption proved particularly devastating to German military effectiveness. Proximity fuses had an uncanny ability to sever telephone wires stretched between command posts and frontline units. German commanders found themselves blind and deaf, unable to coordinate responses to American attacks. Radio communications became essential, but were vulnerable to American intercepts and jamming. The Wehrmacht's carefully constructed command structure began to collapse under the weight of severed connections. Lieutenant von St. Colonel Wilhelm Euben, a Prussian officer with experience dating back to the Polish campaign, wrote about the dis in his diary, Integration of Military Communications. Our telephone lines are cut faster than our engineers can repair them. The American shells seem to seek out our communication wires with supernatural precision. Battalion commanders cannot reach their companies. Company commanders cannot contact their platoons. We are fighting blind, each unit isolated and unable to coordinate with neighboring forces. German artillery officers, studying American shell fragments, discovered shrapnel patterns that defied conventional ballistics. The metal pieces showed consistent distribution, suggesting detonation at optimal altitude for maximum ground coverage. German engineers calculated that achieving such precision would require impossible accuracy in timing mechanisms. Their own proximity fuse experiments had failed precisely because creating reliable timing circuits proved beyond their technological capabilities. The industrial requirements for proximity fuse production astounded German intelligence analysts who managed to piece together fragments of information. American factories were producing millions of devices that German engineers considered impossible to manufacture. Each fuse required precision assembly of over 100 electronic components using techniques that exceeded German industrial capabilities. The scale of production suggested an electronics manufacturing capacity that dwarfed anything in the Reich. Reichsminister Albert Speer, responsible for German war production, received intelligence reports detailing American proximity fuse manufacturing that he initially dismissed as Allied propaganda. The numbers seemed impossible. American industry was allegedly producing electronic devices at rates that exceeded German ammunition production. Each device contained more sophisticated electronics than German radar installations. If accurate, the report suggested American technological superiority that could not be overcome through traditional industrial mobilization. German scientists working on proximity fuse development had encountered every technical obstacle that American researchers faced, but lacked the resources and industrial infrastructure to overcome them. Dr. Heinrich Weber, leading German proximity fuse research at the Telefunken laboratories, had correctly identified the fundamental challenges. His team had developed theoretical solutions to most problems, but could not translate theories into mass-producible devices. Weber's research notes, captured after the war, revealed sophisticated understanding of proximity fuse principles. German scientists knew exactly what needed to be accomplished. They understood the radar technology, the miniaturization requirements, and the environmental challenges. What they lacked was the industrial ecosystem capable of transforming laboratory prototypes into battlefield weapons. American success stemmed not from superior theoretical knowledge, but from unmatched manufacturing capabilities. The contrast in industrial approaches revealed fundamental differences between American and German technological development. German research emphasized perfection and theoretical elegance. American development prioritized practical solutions and mass production. German engineers created beautiful prototypes that worked flawlessly in laboratory conditions. American engineers created robust devices that functioned reliably in combat environments while being manufactured by the millions. This philosophical difference extended throughout both nations' military research programs. German scientists pursued technically superior solutions that required precision manufacturing and exotic materials. American researchers accepted performance compromises in exchange for production simplicity and manufacturing scalability. The proximity fuse represented the triumph of practical engineering over theoretical perfection. German military leadership gradually recognized they faced an opponent with technological capabilities that exceeded their own understanding. General Heinz Guderian, architect of German armoured tactics, wrote to OKW headquarters describing encounters with American proximity fuses. The enemy possesses artillery capabilities that render our tactical doctrines obsolete. Their shells expel precision that suggests sowed with technological superiority we cannot match. Our forces suffer casualties from weapons we cannot comprehend, using methods we cannot counter. The captured ammunition dump incident during the Battle of the Bulge exemplified German technological blindness. On December 23, 1944, elements of the 1st SS Panzer Division overran an American artillery position near Malmedy, capturing over 20,000 proximity fuses along with conventional ammunition. German ordnance specialists examined the strange devices but classified them as defective American shells with faulty timing mechanisms. Obersturmbannführer Klaus Weber, commanding the Ordnance Evaluation Team, filed a report dismissing the captured fuses as evidence of declining American manufacturing quality. The devices appeared to contain unnecessary electronic components that served no obvious purpose. German engineers concluded the Americans were wasting scarce materials on overly complex ammunition that probably malfunctioned more often than it functioned properly. The fuses were set aside as curiosities rather than analysed as revolutionary weapons. This intelligence failure occurred despite German forces having captured thousands of examples of the technology that was systematically destroying their military effectiveness. The fuse contained complete radar systems that German scientists had spent years trying to develop. Every component represented solutions to problems that had stumped German researchers. Yet German preconceptions about technological impossibility prevented recognition of what they possessed. The irony deepened when German engineers attempted to reverse engineer captured American electronics equipment. Teams of technicians carefully disassembled radios, radar sets, and communications gear, documenting every component and circuit. These same engineers had proximity fuses sitting in storage rooms, but never subjected them to similar analysis because their theoretical framework insisted such devices could not function. Dr. Ferdinand Braun, leading German electronics research at Siemens, received samples of captured American equipment for analysis. His team produced detailed reports on American radar technology, radio communications, and electronic manufacturing techniques. When asked about the strange artillery shells found with American ammunition, Braun dismissed them as irrelevant to serious technological assessment. His expertise told him that miniaturized radar systems were impossible given current electronics limitations. The German scientific establishment had created its own intellectual prison. Their theoretical understanding of proximity fuse challenges was so complete, their analysis of technical obstacles so thorough, that they could not conceive of practical solutions. American engineers had solved problems that German scientists had proven could not be solved. This created a cognitive dissonance that prevented German recognition of American technological achievements. Meanwhile, American proximity fuses continued their devastating work across European battlefields. Every German attack faced artillery that seemed to possess supernatural accuracy. Every defensive position became vulnerable to airbursts that ignored conventional cover. Every communication line became a target for shells that exploded at precisely the right altitude to sever connections. German forces found themselves fighting an enemy whose weapons obeyed different physical laws than their own. The transformation became most apparent during night operations, when German forces attempted to move under cover of darkness. Traditional artillery required visual spotting or pre-registered targets to achieve effectiveness after sunset. Proximity fuses eliminated these limitations entirely. American gunners could fire into areas where German movements were suspected, confident that their shells would detonate at optimal altitude, regardless of what they encountered below. Hauptmann Friedrich Kellner, commanding a Wehrmacht supply convoy near Bastogne, experienced this technological nightmare firsthand. His unit had successfully moved supplies at night for weeks, using routes carefully chosen to avoid American observation posts. On January 3, 1945, his convoy encountered something that defied every tactical principle he understood about nighttime artillery. The first shells arrived without warning, exploding 30 feet above the road with brilliant flashes that illuminated the entire column. Kellner counted 12 trucks destroyed in the first salvo. His drivers scattered into roadside ditches, abandoning vehicles loaded with ammunition and medical supplies desperately needed by German forces defending Bastogne. The American gunners continued firing for 20 minutes, their shells exploding with mechanical precision above every piece of cover his men sought. Kellner's after-action report captured the psychological devastation of encountering proximity fuses. The enemy artillery demonstrated capabilities that seemed to violate natural laws. Shells exploded above us without striking anything solid. The timing was perfect, as if American gunners could see our positions despite complete darkness. My men emerged from the barrage convinced they had witnessed supernatural phenomena. Several requested transfer to rear areas, claiming they could no longer function effectively against weapons they could not comprehend. German military intelligence struggled to develop explanations for American artillery effectiveness that wouldn't shatter troop morale. Official reports described improved American training, better communications between forward observers and gun crews, and superior ammunition quality. These explanations preserved the illusion that German forces faced conventional weapons wielded with exceptional skill rather than revolutionary technology that rendered their tactics obsolete. The truth proved far more devastating than German leadership dared acknowledge. American artillery had evolved beyond anything German military doctrine could address. Every tactical manual, every training program, every defensive procedure developed through years of combat experience had become worthless overnight. German forces were fighting tomorrow's war with yesterday's understanding of how artillery functioned. General Oberst Hasso von Manteuffel, commanding the 5th Panzer Army during the Ardennes offensive, recognized the implications of American artillery superiority. His situation reports to OKW headquarters described tactical problems that seemed impossible to solve using conventional military methods. American gunners achieved destruction rates that suggested either perfect intelligence about German positions or weapons that functioned according to unknown principles. Von Manteuffel's staff officers developed increasingly elaborate theories to explain American artillery effectiveness. Some suggested extensive spy networks providing real-time intelligence about German troop movements. Others proposed advanced sound detection equipment that allowed precise targeting of German positions. A few suggested American development of infrared technology that permitted accurate night firing. None considered the possibility that American shells contained miniaturized radar systems because German experts had proven such devices were impossible to build. The proximity fuse's impact extended beyond immediate battlefield effectiveness to fundamental changes in how warfare was conducted. German tactical doctrine emphasized concentration of force at decisive points. Massed formations of infantry and armor would overwhelm American positions through coordinated assaults. These tactics had proven successful against British and Soviet forces who relied on conventional artillery that required direct hits for maximum effectiveness. Against proximity fuses, German tactical concentration became tactical suicide. Massed formations presented ideal targets for airbursts that could devastate entire units with single salvos. German commanders discovered that their most effective tactical doctrine had become their greatest vulnerability. Dispersed formations reduced casualties but made coordinated attacks impossible. The Wehrmacht faced a tactical dilemma with no satisfactory solution. Oberst Heinrich Müller, commanding the 352nd Infantry Division's artillery regiment, documented the evolution of German tactical thinking in his war diary. Our traditional methods of concentration and breakthrough have become obsolete. American artillery destroys massed formations with efficiency that makes conventional assault impossible. We must disperse our forces to survive their guns, but dispersed forces cannot achieve breakthrough against prepared positions. We are caught between tactical requirements that cannot be reconciled using available methods. The industrial implications of proximity fuse technology gradually became apparent to German economic planners. American factories were producing millions of sophisticated electronic devices while simultaneously manufacturing conventional ammunition, vehicles, aircraft, and weapons. The scale of production suggested industrial capacity that dwarfed anything in occupied Europe. German war production, operating at maximum efficiency since 1942, could not approach American manufacturing output, even in basic categories like steel and aluminum. Reichsminister Speer's production, hopeless mathematics of industrial reports revealed the competition with America. German factories produced approximately 40,000 artillery shells daily across all calibers. American industry manufactured proximity fuse at rates approaching 100,000 units daily while maintaining production of conventional ammunition. Each American proximity fuse contained more sophisticated electronics than German radio equipment issued to battalion commanders. The technological gap extended beyond individual devices to entire industrial ecosystems. American proximity fuse production required precision manufacturing capabilities, advanced metallurgy, sophisticated quality control, and complex supply chains coordinating hundreds of subcontractors. German industry possessed some of these capabilities but lacked the integrated infrastructure necessary for mass production of complex electronic systems. Dr. Ferdinand Porsche, whose engineering teams developed advanced German weapon systems, submitted reports to the Reich Ministry describing American technological achievements that seemed to exceed physical possibilities. American factories were allegedly producing electronic devices at costs lower than German manufacturers achieved for simple mechanical components. If accurate, these reports suggested manufacturing efficiency that German industry could never match even under ideal conditions. The proximity fuse's success demonstrated American mastery of what would later be called systems engineering. The weapon required simultaneous breakthroughs in electronics, manufacturing, materials science, and production management. No single innovation made proximity fuses possible. Instead, coordinated advances across multiple disciplines created synergistic effects that transformed laboratory curiosities into battlefield weapons. German research and development operated differently, emphasizing individual brilliance and theoretical perfection. German scientists created elegant solutions to specific problems, but struggled to coordinate multiple innovations into practical weapon systems. The Luftwaffe possessed advanced jet engines, German chemists had developed superior explosives, German electronics engineers understood radar principles, but these achievements never converged into integrated weapon systems that matched American proximity fuses. Lieutenant General George Patton's reaction to proximity fuse effectiveness captured American understanding of their technological achievement. His letter to the War Department described combat results that seemed to defy conventional military logic. "The new shell with the funny fuse is devastating. We caught a German battalion trying to cross the Sauer River with a concentration fire and killed by actual count 702. I think when all armies get this shell, we will have to devise some new method of warfare." Patton's assessment proved prophetic. Proximity fuses represented more than improved artillery effectiveness. They demonstrated that technological superiority could render traditional military tactics obsolete overnight. German forces trained for years in combat techniques that became worthless when confronted with weapons that functioned according to different principles than anything in their experience. The Battle of the Bulge marked the transition from proximity fuse experimentation to systematic deployment across American artillery units. By January 1945, every American artillery battalion in Europe possessed stocks of proximity-fused ammunition. German forces discovered that American artillery effectiveness had improved dramatically across the entire front simultaneously. German defensive positions that had withstood months of conventional bombardment became untenable under proximity fuse attacks. The Siegfried Line fortifications, designed to resist direct artillery hits, offered no protection against airbursts that exploded above bunker roofs. German engineering had anticipated every threat except shells that detonated without striking solid objects. Oberst Wilhelm Vierbig, commanding fortress troops along the Siegfried Line, reported to Army Group B headquarters that American artillery had developed capabilities that made fixed fortifications obsolete. His bunkers, constructed with reinforced concrete roofs designed to deflect direct hits, became death traps when American shells exploded above them and sent shrapnel through ventilation systems, observation ports, and gun embrasures. The psychological warfare aspects of proximity fuses proved as significant as their physical destruction. German soldiers developed what American intelligence officers termed fuse fear, a psychological condition characterized by reluctance to move in open areas and obsessive concern about overhead protection. Medical officers reported increasing numbers of combat fatigue cases among troops who had previously shown exceptional resilience under conventional artillery fire. Sanitätsoffizier Dr. Karl Weber, serving with the 12th SS Panzer Division, documented the mental health impact of proximity fuse attacks in his medical reports. Soldiers who survived airbursts displayed symptoms unlike anything observed under conventional bombardments. They spoke obsessively about shells that exploded without hitting anything, about shrapnel that seemed to fall from empty sky, about American gunners who possessed supernatural abilities to place explosions at precisely the right altitude for maximum effect. German field hospitals reported unusual injury patterns that medical personnel struggled to explain. Proximity fuse shrapnel created wounds that suggested detonations at optimal distances for maximum casualty effect. Traditional artillery injuries resulted from shell fragments traveling at various angles and velocities depending on ground impact conditions. Proximity fuse casualties showed consistent wound patterns indicating shrapnel distribution from carefully calculated airburst heights. The medical evidence provided additional confirmation that German forces faced revolutionary weapons technology, but German medical officers lacked the technical knowledge to interpret what they observed. Wound patterns that should have revealed proximity fuse capabilities were documented as statistical anomalies rather than evidence of systematic technological advancement by American forces. Meanwhile, American artillery units reported combat effectiveness that exceeded their most optimistic expectations. Battery commanders discovered that proximity-fused shells achieved destruction rates 3 to 4 times greater than conventional ammunition against personnel targets. Area targets that previously required sustained bombardment could be neutralized with brief, accurate concentrations that conserved ammunition while maximizing psychological impact. Major Robert Sterling, commanding the 155th Artillery Battalion, documented proximity fuse performance in his unit's combat history. Our effectiveness increased dramatically when we received the new ammunition. German positions that had resisted conventional bombardment for weeks were neutralized in single-fire missions. The enemy appeared unable to develop countermeasures against weapons they could not understand. Their tactical responses suggested complete confusion about how our shells achieved such devastating accuracy. The strategic implications of proximity fuse technology extended far beyond immediate battlefield results. German military leadership recognized they faced an opponent whose technological capabilities seemed to improve continuously while their own weapons remained static. American industry demonstrated the capacity to develop revolutionary technologies while maintaining production of conventional systems. German war production, operating at maximum capacity, could barely sustain existing weapons programs without resources for major innovations. General Oberst Heinz Guderian, in his final situation reports before dismissal, warned OKW that German forces faced technological obsolescence that could not be overcome through traditional military methods. The enemy possesses weapons that render our tactical doctrines ineffective and our defensive preparations worthless. Their technological superiority appears to increase with each month of the war. We cannot match their production capacity or their innovation rate using available resources. The proximity fuse had achieved exactly what American military planners intended. It transformed artillery from a weapon requiring skilled operators and favorable conditions into a system that delivered devastating effectiveness under any circumstances. German forces discovered that their hard-won combat experience, their carefully developed tactics, and their sophisticated defensive preparations had become liabilities rather than advantages when confronted with technology that operated according to principles they could not comprehend. As German forces retreated across the Rhine in early 1945, their intelligence services finally began piecing together fragments of information about American proximity fuse technology. Interrogation reports from captured American artillery crews mentioned mysterious shells that exploded without hitting targets. German signal intercepts revealed American radio communications discussing ammunition with strange designations that didn't match conventional ordnance classifications. Luftwaffe pilots reported increasing encounters with anti-aircraft fire that seemed to anticipate their evasive maneuvers with supernatural precision. Oberst Friedrich Halder, commanding Army Group G's intelligence section, compiled these scattered reports into a comprehensive assessment that reached disturbing conclusions. The evidence suggested American development of artillery technology that fundamentally altered the mathematics of battlefield destruction. Traditional German calculations about casualty rates, ammunition expenditure, and tactical effectiveness had become worthless overnight. American gunners achieved results that should have required perfect intelligence and impossible accuracy. Halder's report documented systematic patterns in American artillery effectiveness that defied conventional explanation. German units reported casualty rates from American bombardments that exceeded anything experienced against British or Soviet forces. The destruction appeared concentrated in areas where German troops sought cover, as if American shells specifically targeted protective positions. Communication disruptions occurred with mechanical regularity that suggested deliberate severing of telephone lines rather than random destruction. Most disturbing to German analysts were reports from multiple fronts describing identical phenomena. American artillery in Italy demonstrated the same uncanny effectiveness observed in France. Pacific Theater intelligence revealed similar Japanese complaints about American anti-aircraft capabilities that seemed to violate natural laws. The consistency across theatres suggested systematic deployment of revolutionary technology rather than isolated tactical innovations. Dr. Wilhelm Ohnesorg, Reich Postmaster General, an electronics specialist, received fragments of captured American equipment for technical analysis. His engineers examined radio components, radar assemblies, and communications devices that demonstrated manufacturing precision exceeding German capabilities. American electronics showed consistent quality control and miniaturization techniques that suggested industrial processes unknown to German manufacturers. Ohnesorg's technical assessment revealed disturbing implications for German military production. American electronics incorporated design principles that German engineers understood theoretically but could not implement practically. The manufacturing tolerances required for such devices exceeded German industrial capabilities even under peacetime conditions. Wartime production of comparable equipment would require complete reconstruction of German electronics industry using methods and materials unavailable in occupied Europe. The captured equipment analysis intensified German concerns about technological inferiority that extended beyond individual weapons to entire industrial systems. American factories produced sophisticated electronics while maintaining outputs of conventional military equipment. German industry, operating at maximum capacity since 1943, struggled to maintain production of existing weapons without resources for major technological upgrades. Reichsmarshal Hermann Göring, reviewing intelligence reports about American technological capabilities, initially dismissed assessments as defeatist propaganda designed to undermine German morale. His staff officers presented evidence of American industrial achievements that seemed to exceed physical possibilities. American aircraft production allegedly surpassed German output by margins that suggested either fabricated statistics or manufacturing capabilities beyond German comprehension. Göring's skepticism dissolved when Luftwaffe pilots began reporting encounters with American fighters whose performance exceeded anything in German intelligence files. American aircraft demonstrated range, firepower, and durability that suggested technological advances years ahead of German development programs. These same aircraft appeared in combat within months of intelligence reports, indicating American production speeds that made German manufacturing look primitive by comparison. The accumulated evidence forced German leadership to confront uncomfortable realities about their opponent's technological superiority. American industry demonstrated capabilities that German planners had considered impossible when calculating wartime production requirements. The United States possessed manufacturing infrastructure that could simultaneously develop revolutionary weapons while maintaining conventional production at scales exceeding German capacity. Lieutenant General Gotthard Heinrici, commanding Army Group Vistula during the final months of the war, documented the psychological impact of technological inferiority on German combat effectiveness. His situation reports described troops who had lost confidence in their weapons and tactics when confronted with American technology they could not understand or counter. Heinrici's frontline units reported encounters with American equipment that seemed to function according to different physical laws than German weapons. American tanks survived direct hits from German anti-tank guns that should have guaranteed destruction. American aircraft continued flying after sustaining damage that would have downed any Luftwaffe fighter. American artillery achieved accuracy that German gunners considered impossible under battlefield conditions. The demoralization extended beyond individual encounters to fundamental questions about German technological competence. Soldiers who had entered the war confident in German engineering superiority discovered their weapons were inferior to American equivalents across multiple categories. Veterans who had survived years of combat against British and Soviet forces found themselves outclassed by American technology they had never encountered. Hauptmann Klaus Weber, commanding an artillery battery in the Ruhr pocket, experienced the technological disparity firsthand during the final weeks of the war. His unit possessed 88mm guns that had proven effective against Allied armour throughout the conflict. Against American forces equipped with proximity fuses, his carefully prepared positions became death traps that his crews could not abandon without facing certain destruction. Weber's battery had survived conventional counter-battery fire through techniques developed over years of combat experience. German gunners learned to fire rapidly and displace immediately, avoiding mobility and camouflage return fire through oufflage. American proximity-fused counter-battery fire eliminated these survival techniques entirely. Shells that exploded above German positions without requiring direct hits made displacement impossible and camouflage worthless. The battery's destruction occurred with mechanical precision that Weber found more terrifying than random battlefield violence. American shells arrived in carefully timed sequences that prevented German crews from escaping their positions. The first salvo disabled vehicles and communications equipment. Subsequent rounds exploded at precisely calculated intervals to catch crews attempting to flee. Weber counted 17 of his 24 men killed or wounded in less than 3 minutes of bombardment. Weber's after-action report, written while hiding in a bombed-out farmhouse, captured the psychological devastation of encountering technology that seemed to anticipate every tactical response. The enemy artillery demonstrated capabilities that made our training and experience worthless. They destroyed us with methods we could not understand, using weapons that functioned beyond our comprehension. I have commanded artillery for 4 years of this war, and I no longer understand how artillery works. German artillery specialists studying American shell fragments discovered metallurgy and manufacturing techniques that revealed disturbing implications about American industrial capacity. The precision of American ammunition components exceeded German standards for critical weapon systems. Each shell represented manufacturing capabilities that German industry could not match even when producing small quantities under ideal conditions. Oberst Heinrich Müller, directing German ordnance evaluation, submitted reports to OKW describing American manufacturing achievements that seemed to violate economic principles. American ammunition showed consistent quality control across millions of units produced by hundreds of manufacturers. German industry achieved comparable precision only through hand selection and individual testing that made mass production impossible. The manufacturing evidence suggested American industrial organization that operated according to different principles than German war production. American factories coordinated complex supply chains involving thousands of subcontractors while maintaining quality standards that exceeded German capabilities. The scale of coordination required for such production seemed beyond human organizational capacity, using available management techniques. German industrial experts studying American manufacturing methods encountered systems thinking that transcended their understanding of production management. American factories integrated multiple technological innovations into coherent production systems that achieved results exceeding the sum of individual components. German industry excelled at specific technologies, but struggled to coordinate innovations into systematic advantages. Dr. Ferdinand Porsche, whose engineering teams had developed advanced German weapons, submitted assessments of American technological achievements that challenge fundamental assumptions about industrial possibilities. American manufacturers demonstrated capabilities that German theory suggested required decades of development and resources unavailable during wartime production. The implications extended beyond military applications to questions about post-war economic competition. Porsche's technical analysis revealed American mastery of manufacturing techniques that German industry had considered theoretical possibilities rather than practical applications. American factories achieved precision and efficiency that German engineers associated with laboratory conditions rather than mass production environments. The systematic nature of American achievements suggested industrial philosophy fundamentally different from German approaches. Meanwhile, American proximity fuse production continued expanding as military demand increased across all theaters of operation. Pacific campaigns required millions of anti-aircraft rounds for defense against kamikaze attacks. European operations consumed proximity-fused ammunition at rates that would have bankrupted smaller nations. American industry met both requirements while developing improved variants with enhanced capabilities. The production statistics that German intelligence managed to compile suggested American manufacturing capacity that defied rational calculation. American factories produced proximity fuses at costs lower than German manufacturers achieved for conventional ammunition. Each fuse contained electronics more sophisticated than German radar equipment, while being manufactured faster than German assembly lines produced simple artillery shells. Major General Leslie Groves, directing American proximity fuse production coordination, received reports from factory managers describing productivity improvements that seemed to violate known manufacturing principles. American workers, many of whom had never seen electronics before the war, achieved assembly precision that exceeded German standards, while working at speeds that made German production methods appear primitive. The human element of American manufacturing proved as revolutionary as the technology itself. American factories employed millions of workers, including women and minorities excluded from German war production, who demonstrated capabilities that challenged Nazi ideological assumptions about industrial capacity. German observers noted that American productivity increased when workers were treated as valuable contributors rather than expendable resources. American proximity fuse factories operated as integrated communities where workers understood their contribution to overall military objectives. German industry relied on coercion and surveillance to maintain production levels that American factories exceeded through voluntary cooperation and shared purpose. The organizational differences suggested social systems that produced technological advantages extending beyond individual innovations. Colonel William Tompkins, commanding American ordnance production in the Midwest, documented manufacturing achievements that exceeded pre-war projections by orders of magnitude. American factories converted from civilian production to military manufacturing in months rather than years. Workers mastered complex assembly techniques that German specialists required years to learn. Quality control systems ensured consistent results across millions of units produced under wartime conditions. The proximity fuse represented more than technological achievement. It demonstrated American capability to identify critical military requirements, develop revolutionary solutions, and implement mass production systems that transformed laboratory prototypes into battlefield weapons. German observers recognized they faced an opponent whose technological capabilities improved continuously while their own remained static or declined. General Oberst Alfred Jodl, in his final intelligence briefings before German surrender, acknowledged that American technological superiority had rendered traditional military calculations obsolete. The enemy possesses industrial and scientific capabilities that exceed our understanding of what should be possible during wartime production. Their weapons improve constantly while ours deteriorate due to material shortages and production difficulties. German military leadership finally understood they had entered the war with fundamental misconceptions about American capabilities. The nation they had dismissed as industrially inferior possessed manufacturing systems that could simultaneously develop revolutionary weapons while producing conventional equipment at scales that dwarfed German capacity. American industry demonstrated flexibility and innovation that German central planning could not match. The proximity fuse's success story became a symbol of American technological triumph that extended far beyond its immediate military applications. German engineers who survived the war carried knowledge of American achievements that would influence European industrial development for decades. The weapon that German scientists had declared impossible became proof that American ingenuity could overcome any technical obstacle when supported by adequate resources and organizational commitment. As German resistance collapsed in April 1945, proximity fuses continued their devastating work against the final desperate counterattacks. German soldiers who had endured years of combat against conventional weapons discovered that their survival techniques offered no protection against technology that seemed to possess intelligence of its own. The shells that exploded without hitting anything had become the soundtrack of German defeat, a mechanical precision that announced the arrival of a new age in military technology where American innovation reigned supreme. The psychological transformation of German military thinking accelerated during the spring of 1945 as proximity fuse became standard ammunition for American artillery units across all fronts. What had begun as isolated encounters with mysterious exploding shells evolved into systematic exposure to technology that challenged every assumption about how warfare functioned. German field commanders discovered their tactical manuals had become obsolete overnight, their defensive preparations worthless against weapons that ignored conventional limitations. Oberst Friedrich Kellner, directing defensive operations along the Elbe River, documented the complete breakdown of German tactical doctrine in his final situation reports. His experienced Wehrmacht units, veterans of campaigns from Poland to Normandy, found themselves psychologically shattered by artillery that seemed to possess supernatural abilities. Traditional German defensive tactics emphasized using terrain features for protection, constructing overlapping fields of fire, and maintaining communication between strong points. Proximity fuses rendered these time-tested methods suicidal. Kellner's troops discovered that seeking cover in buildings made them vulnerable to airbursts that exploded above rooftops and sent shrapnel through windows and doorways. Foxholes became death traps when shells detonated at precisely calculated heights to maximize downward fragmentation patterns. Communication trenches, carefully constructed to provide protected movement between positions, became killing zones where exploding shells created crossfire patterns of metal fragments that no amount of armor could deflect. The veteran officer's diary entries revealed the psychological devastation of confronting technology that operated beyond German comprehension. His soldiers, many of whom had survived years of combat against British and Soviet forces, developed what medical personnel termed proximity neurosis, a condition characterized by obsessive fear of overhead explosions and inability to function effectively in open terrain. Men who had charged enemy positions under conventional artillery fire refused to leave covered positions when American guns opened fire. German medical officers studying proximity neurosis cases discovered symptoms unlike anything documented in previous conflicts. Soldiers described shells that seemed to follow them, exploding at exactly the right moment to cause maximum casualties. Veterans spoke of American gunners who possessed supernatural abilities to time detonations with mathematical precision. The mechanical regularity of proximity fuse explosions created psychological trauma that conventional artillery, with its random destruction patterns, had never produced. Sanitätsoffizier Dr. Wilhelm Hoffmann, serving with Army Group Center during the final retreat across Germany, documented medical evidence that German forces faced revolutionary weapons technology. Casualty patterns from American artillery attacks showed consistent wound distributions, suggesting systematic optimization of shrapnel effects. Traditional artillery injuries varied widely depending on ground impact conditions, shell angle, and target positioning. Proximity fuse casualties displayed uniform characteristics, indicating detonations at carefully calculated altitudes. The medical data provided additional confirmation that American artillery had evolved beyond anything German military doctrine addressed. But German medical personnel lacked technical knowledge to interpret what they observed. Wound patterns that clearly indicated airburst detonations were recorded as statistical anomalies rather than evidence of systematic technological advancement. German military medicine, like German military engineering, remained trapped by preconceptions that prevented recognition of American innovations. Meanwhile, American artillery effectiveness continued improving as production facilities refined proximity fuse manufacturing processes. Factory modifications eliminated early reliability problems while reducing costs to levels that made the revolutionary ammunition economically practical for sustained combat operations. American gunners discovered they possessed weapons that transformed artillery from an area suppression system into a precision destruction tool, capable of neutralizing specific targets with minimal ammunition expenditure. Captain Robert Harrison, commanding Battery A of the 95th Field Artillery Battalion, documented proximity fuse performance during the final drive across Germany. His unit achieved destruction rates that exceeded peacetime training projections by factors that seemed impossible under combat conditions. German positions that should have required sustained bombardment were neutralized with brief, accurate concentrations that demonstrated the mathematical precision of airburst technology. Harrison's battery discovered that proximity fuses eliminated traditional limitations on artillery effectiveness. Conventional ammunition required favorable observation conditions, accurate range estimation, and multiple adjustment rounds to achieve satisfactory results. Proximity-fused shells delivered devastating effectiveness regardless of visibility, terrain conditions, or target identification accuracy. American gunners could engage suspected enemy positions with confidence that their ammunition would detonate at optimal altitude for maximum destruction. The tactical implications revolutionized American artillery doctrine throughout the European theater. Battery commanders abandoned complex firing procedures developed through decades of conventional artillery experience. Traditional techniques for bracketing targets, adjusting for wind and atmospheric conditions, and calculating optimal shell trajectories became unnecessary when ammunition contained internal guidance systems that ensured proper detonation timing. Major General Edward Brooks, commanding 9th Corps Artillery, submitted tactical assessments describing proximity fuse capabilities that transformed corps-level fire. American artillery units achieved support planning effects with single battalions that previously required entire artillery regiments. The concentration of destructive power allowed American commanders to support multiple operations simultaneously while maintaining devastating firepower against priority targets. German intelligence services, recognizing the systematic nature of American artillery improvements, intensified efforts to understand the technology that was destroying Wehrmacht effectiveness. Captured American equipment underwent detailed technical analysis by teams of specialists who had successfully reverse-engineered British radar systems and Soviet weapons innovations. The proximity fuse components, recovered from unexploded shells, revealed manufacturing techniques that German engineers found incomprehensible. Oberingenieur Klaus Weber, directing German electronics research at the Telefunken laboratories, received samples of American proximity fuse components for comprehensive technical evaluation. His team of experienced engineers who had developed advanced German radar and communication systems encountered that exceeded their most manufacturing precision projections. American electronic optimistic theoretical components showed tolerances measured in thousandths of inches achieved through mass production techniques that German industry considered impossible. Weber's technical assessment revealed disturbing implications about American manufacturing capabilities that extended far beyond proximity fuse production. The miniaturization techniques demonstrated in captured components suggested industrial processes that German theory indicated required decades of development and investment levels beyond wartime possibility. Each proximity fuse represented technological achievements that German research programs had identified as long-term objectives rather than immediate practical applications. The manufacturing evidence indicated American industry had solved fundamental problems in electronics production that German engineers were still attempting to understand theoretically. Mass production of precision electronic components required integration of advanced metallurgy, quality control systems, and assembly techniques that German industry had never achieved even in laboratory conditions. The systematic nature of American manufacturing suggested technological capabilities that challenged German assumptions about industrial development. German technical intelligence gathered additional evidence of American technological superiority through examination of captured aircraft, vehicles, and communications equipment. Every category of American military hardware demonstrated consistent advancement over German equivalents. American tanks incorporated armor, metallurgy, and mechanical systems that exceeded German engineering standards. American aircraft showed structural design and manufacturing quality that German industry could not match using available materials and production methods. The accumulated technical evidence forced German military leadership to confront systematic American technological superiority that extended across all categories of military equipment. American industry demonstrated capability to develop revolutionary innovations while maintaining production of conventional systems at scales that dwarfed German manufacturing capacity. The proximity fuse represented one example of American technological achievement that German intelligence could document but could not explain or counter. General Oberst Wilhelm Keitel, reviewing comprehensive intelligence assessments of American military capabilities, acknowledged that German strategic planning had been based on fundamental misconceptions about enemy industrial potential. American technological achievements suggested scientific and manufacturing resources that exceeded German intelligence projections by orders of magnitude. The proximity fuse alone demonstrated American capability to transform theoretical concepts into mass-produced weapons within timeframes that German planning had considered impossible. German prisoners of war, interrogated by American intelligence officers, provided additional confirmation of proximity fuse psychological impact on Wehrmacht morale. Captured soldiers consistently described American artillery as possessing supernatural accuracy that made traditional defensive tactics worthless. German veterans who had survived years of combat against British and Soviet forces spoke of American weapons with mixture of fear and incomprehension that American interrogators found both disturbing and encouraging. Unteroffizier Heinrich Müller, captured during the collapse Group B of Army, described proximity fuse attacks in terms that revealed complete psychological breakdown of German tactical confidence. His unit had been subjected to conventional artillery throughout the war without losing combat effectiveness. American proximity-fused bombardments produced casualties and demoralization that exceeded anything experienced during 3 years of Eastern Front combat. Müller's testimony revealed how proximity fuses had shattered German soldier confidence in their weapons, tactics, and leadership. Men who had followed orders without question began refusing to leave protective positions when American artillery opened fire. Unit cohesion, maintained through years of brutal combat, disintegrated when confronted with weapons that seemed to violate natural laws. German military discipline, based on mutual trust between officers and enlisted personnel, collapsed when leaders could not explain or counter American technological capabilities. American psychological warfare specialists recognized proximity fuse potential for undermining German military morale beyond immediate battlefield destruction. Artillery that exploded without hitting targets created psychological uncertainty that proved more devastating than conventional bombardment. German soldiers developed obsessive concern about overhead protection that interfered with tactical movement and combat effectiveness. Captain James Morrison, attached to 12th Course Intelligence Section, documented proximity fuse psychological warfare effects through interrogation of German prisoners and analysis of captured documents. German medical reports described increasing numbers of combat fatigue cases among troops exposed to American artillery. Veterans who had demonstrated exceptional resilience under conventional bombardment showed symptoms of psychological breakdown after experiencing proximity fuse attacks. Morrison's analysis revealed that proximity fuse created psychological pressure that accumulated over time rather than producing immediate dramatic effects. German soldiers gradually lost confidence in their ability to survive American artillery attacks using traditional protective methods. The mechanical precision of airburst detonations suggested American gunners possessed intelligence about German positions that made evasion impossible and resistance futile. German field commanders attempted to develop countermeasures against proximity fuse technology, but discovered their tactical options were severely limited by environmental and resource constraints. Traditional methods for reducing artillery effectiveness required mobility, concealment, and dispersion that German forces could not maintain while conducting defensive operations against superior American ground forces. Every adaptation to proximity fuse threats created vulnerabilities to other American weapon systems. Oberst Wilhelm Stemmermann, commanding the 276th Infantry Division during the final defense of the Ruhr Pocket, documented German attempts to counter American artillery superiority through tactical modifications. His division experimented with underground movement systems, enhanced camouflage techniques, and dispersed defensive positions designed to minimize casualties from airburst attacks. Every countermeasure proved inadequate against American artillery that seemed to anticipate German tactical responses. Stemmermann's division discovered that underground fortifications provided protection from proximity fuse attacks, but severely limited tactical flexibility and communication capabilities. German defenders became isolated in bunker systems that American infantry could bypass or destroy using conventional demolitions. Enhanced camouflage proved worthless against artillery that exploded above concealed positions without requiring visual identification of targets. Dispersed defensive positions reduced casualties from individual proximity fuse attacks, but made coordinated resistance impossible against American combined arms operations. German units spread across wide areas could not concentrate firepower against American attacks or provide mutual support during enemy penetrations. The tactical modifications required to counter proximity fuses undermined German defensive effectiveness against conventional American weapons. The strategic implications of proximity fuse technology became apparent to German high command as American forces advanced across the Rhine and deep into German territory. Wehrmacht defensive capabilities, based on maximizing casualties against attacking forces through concentrated firepower and prepared positions, had been systematically neutralized by artillery that ignored traditional limitations. German strategic planning, developed through years of combat experience, required complete revision to address American technological superiority. General Oberst Alfred Jodl, directing German strategic planning during the final months of the war, submitted assessments to Hitler's headquarters, acknowledging that proximity fuse technology had rendered traditional defensive calculations obsolete. American artillery achieved destruction rates that exceeded German planning assumptions about casualties required to halt enemy advances. Wehrmacht defensive positions designed to inflict maximum casualties on attacking forces became death traps for German defenders when subjected to proximity fuse bombardments. Jodel's strategic analysis revealed that German military doctrine, refined through years of successful operations against British and Soviet forces, had become counterproductive against American technological capabilities. German defensive tactics emphasized using terrain advantages to channel enemy attacks into prepared killing zones where concentrated firepower could achieve decisive results. American proximity fuses eliminated terrain advantages by creating killing zones wherever shells exploded, regardless of ground conditions or defensive preparations. German strategic planners recognized they faced an opponent whose technological capabilities continued improving while German weapons remained static or deteriorated due to material shortages and production difficulties. American industry demonstrated capacity for continuous innovation that German war economy could not match using available resources and organizational methods. The proximity fuse represented one example of American technological dynamism that suggested systematic superiority across multiple categories of military equipment. The final German counteroffensives of the war demonstrated proximity fuse devastating effectiveness against concentrated formations attempting traditional breakthrough operations. German commanders discovered that massing forces for decisive attacks created ideal targets for American artillery that could destroy entire units with single-fire missions. Wehrmacht tactical doctrine, based on concentration of force at critical points, had become tactical suicide against weapons that maximized effectiveness against concentrated targets. Oberst Friedrich Hauser, directing the final German counterattack near Remagen, experienced proximity fuse technology at its most devastating during carefully planned operations that should have achieved tactical success using conventional military methods. His assault troops, veterans of successful breakthrough operations throughout the war, advanced against American positions using proven tactics that had overcome British and Soviet defenses. American proximity-fused artillery destroyed the attack before German forces could engage enemy positions. Hauser's after-action report described tactical destruction that exceeded anything experienced during years of Eastern Front combat. American shells exploded above German formations with timing precision that suggested perfect intelligence about attack plans and troop dispositions. Traditional German assault tactics, based on rapid advance and overwhelming local superiority, became impossible when American artillery could deliver devastating firepower against moving formations regardless of terrain conditions or visibility limitations. The psychological impact on German assault troops proved as destructive as physical casualties from proximity fuse attacks. Veterans who had successfully conducted breakthrough operations against fortified Soviet positions lost confidence in their tactical abilities when confronted with American weapons that seemed to anticipate their movements. Unit cohesion, essential for successful assault operations, disintegrated when soldiers could not understand or counter American technological capabilities. German military leadership gradually acknowledged that proximity fuse technology represented fundamental transformation in warfare that rendered traditional military calculations obsolete. The weapon that German scientists had declared impossible had become proof of American technological superiority that extended across multiple categories of military equipment. Wehrmacht forces discovered they were fighting an opponent whose industrial capabilities exceeded German comprehension and whose weapons operated according to principles that German military doctrine could not address. As German resistance collapsed during April 1945, proximity fuses continued their systematic destruction of Wehrmacht defensive capabilities across all fronts. German soldiers who had survived years of conventional combat discovered their experience provided no protection against technology that seemed to possess intelligence of its own. The mechanical precision of shells that exploded without hitting targets had become the signature of American military superiority, announcing the arrival of technological warfare that made German weapons and tactics appear primitive by comparison. The final weeks of the European war demonstrated proximity fuse technology at peak effectiveness as American artillery units received unlimited ammunition supplies and unrestricted firing authorization. German defensive positions that had withstood months of conventional bombardment were neutralized within hours of proximity fuse attacks. Wehrmacht units that had maintained combat effectiveness throughout years of brutal warfare disintegrated under artillery fire that operated beyond their understanding or ability to counter. German military intelligence services, in their final reports before national surrender, acknowledged that American technological achievements had transformed warfare in ways that German strategic planning had never anticipated. The proximity fuse represented one example of American innovation that demonstrated systematic superiority in scientific research, industrial production, and military application. German forces had entered the war confident in their technological advantages and ended it confronting American capabilities that exceeded their most pessimistic assessments of enemy potential. The legacy of German proximity fuse denial would extend far beyond immediate military defeat to influence post-war understanding of technological development and international competition. German engineers who had dismissed American innovations as impossible carried knowledge of their miscalculations into peacetime careers, where they applied lessons learned through devastating exposure to superior American technology. The weapon that German theory had proven could not exist became a symbol of American industrial achievement that would shape European technological development for decades after the war's conclusion. The final irony of German proximity fuse denial reached its ultimate expression in the intelligence archives discovered after the war's end. Among the thousands of technical documents captured in Berlin bunkers and research facilities, Allied investigators found detailed German studies of American artillery effectiveness dating back to late 1944. These reports, classified at the highest levels of Wehrmacht intelligence, contained accurate descriptions of proximity fuse capabilities, alongside official explanations that dismissed the technology as propaganda designed to demoralize German troops. Oberst Heinrich Müller's intelligence summary from February 1945 exemplified this cognitive disconnect. His analysis correctly identified proximity fuse effects on German casualties, communication disruptions, and tactical effectiveness. The same report concluded that American claims about electronic artillery fuses represented psychological warfare rather than genuine technological achievement. German intelligence had accurately documented the weapon's devastating impact, while simultaneously denying its existence. The captured documents revealed how German institutional thinking had created intellectual barriers that prevented recognition of American innovations even when confronted with overwhelming evidence. Wehrmacht intelligence officers possessed detailed casualty statistics, wound pattern analysis, and battlefield effectiveness data that clearly indicated revolutionary American artillery technology. Their theoretical framework insisted such devices were impossible, creating explanatory systems that attributed American success to conventional factors like improved training, better communications, or superior manufacturing quality. Dr. Wilhelm Onussorger's final technical assessment, submitted to Reich leadership in March 1945, demonstrated the complete failure of German scientific analysis. His team had examined hundreds of proximity fuse components recovered from battlefields across Europe. Their technical report acknowledged American manufacturing precision that exceeded German capabilities while maintaining that the electronic systems served no practical military purpose. German experts concluded the Americans were wasting resources on overly complex ammunition that probably malfunctioned more often than it functioned properly. The shells that had once been dismissed as impossible fantasies now fell silent across a defeated Germany. In bunkers beneath Berlin, German scientists finally examined the proximity fuses they had captured by the thousands but never recognized. The miniaturized radar systems that German theory had proven could never work lay scattered across laboratory tables, each one a testament to American ingenuity that had rendered an empire obsolete. The funny fuses had spoken their final word, and in their mechanical precision lay the blueprint for a new age where technological superiority would determine the fate of nations.